Okay, everyone, let's begin then. June 2020 paper 1 variant 1 and June 2020 paper 1 variant 3. These are the two papers that we want to focus on today. You will let me know the questions that you find difficult. If you have not responded to the poll in the group yet, please make sure to do that as soon as possible so that we can decide the questions that we want to do. Okay, so right now I see questions 4, 8, 11. And then there are a couple of others as well. Okay, we can start from 3. So questions 3 and 7, these do not have as many votes, but those of you who have asked about it, can you specify which specific part you have problem in? So maybe you can just focus on that part from questions 3 and 7, and the rest of them we will do completely questions 4, 8, and 11. Okay, let's actually go through the paper alongside as well. Then we can see which parts of those questions are relatively difficult. We could perhaps just focus on those difficult parts for some of these other questions that do not have as many votes. What method do we use for question 3? Okay. Okay, let's start with this. June 2020 paper 1 variant 1. This is the first question, AP/GP. Okay, we'll have this binomial. Question number 3. Okay, it's a short one. Let's do this quickly as well. It says each year the selling price of a diamond necklace increases by 5%. Remember, whenever there's a percentage increase, that's a geometric progression. Okay. It increases by 5% of the price the year before. The selling price of the necklace in the year 2000 was $36,000. So in the year 2000, the price was $36,000. And then it increases by 5%. If there's a 5% increase, what that means is, if the original value was 100%, it would increase to 105%. What is 105% in decimals? It's 1.05. That is going to be the ratio of this geometric progression. Okay, whenever you have percentage increase or decrease, that's a geometric progression in this case. Since the percentage increase is given to be 5%, this is how it increases. It increases by a ratio of 1.05 every single time. Okay. We need to write down an expression for the selling price of the necklace n years later, and hence find the selling price in 2008. Okay, now that's actually a good one because often there is a confusion about what this statement means n years later. We are given the starting price, that's in 2000. In 2000, the price is $36,000. And we know that the ratio is going to be 1.05. If you're not sure about that, what you can also do is you can find the value of this number in year 2001. If you can't figure out the ratio directly, just increase 36,000 by 5%. What would that be? 36,000 multiplied by 0.05 plus 36,000. This number would turn out to be 37,800, and then you can divide 37,800 by 36,000, and you would get the same ratio from that as well. So if you can't figure out the ratio directly, this could be another way of doing that as well. Okay. But once we've got the ratio, what we want to do now is we want to write down an expression for the selling price of the necklace n years later. What's the term formula of a GP? The term formula looks like this: Tn equals AR raised to power n minus 1. But remember, in this formula, n represents the position of the term. So what that means is, in the term formula, when n is equal to 1, you get A. And that's the first term, 36,000. When n is equal to 2, you get A times R. That's the second term. That's this. When n is equal to 3, you get AR squared. That is going to be this third term. This n means something else. It says n years later. What that means is, if you're talking about the price of the necklace 1 year later, which term are we talking about? In 2001, it would be 1 year later. So this number is 1 year later. And then this number is 2 years later. What would be the price of the necklace 2 years later? Can you think of that? The starting price is 36,000. Let's actually calculate this one, and that will make it clear how this formula is going to look like for n years later. 36,000 multiplied by 1.05, that will give you this number, and then 1.05 again, that will give you the next number. This is going to be 1.05 squared. So 2 years later is 1.05 squared. 3 years later, it would be 1.05 cube, and then 1.05 raised to power 4, and so on. What happens n years later? So when we say n years later, what is that going to be? This is going to be 36,000 multiplied by 1.05 raised to power n. That is going to be the expression that you get for the selling price of the necklace n years later. That's going to be the number that's going to be the expression that you get from this. Okay, it's not going to be n minus 1. It's going to be n in this case, because we're talking about n years later. So considering this is the first term, 1 year later would be the second term. 2 years later would be the third term. N years later, you would have n plus first term. At this position, the formula is going to look like this: 36,000 into 1.05 raised to power n, and that's what you get. That's the expression that we were looking for. Does that make sense to everyone? Any question on this? This is slightly confusing, and I've not seen many people get this right in the exams. It's like 20-25% of people get this correct in the exam, maybe even less than that. They end up writing n minus 1 here. In this case, this is going to be n. Is that okay? No problems? And now they say, hence find the selling price in 2008. How many years later is that? How many years later is 2008? Remember, we started from 2000. 2008 is 8 years later. So in year 2008, what would the price be? It would be 36,000 into 1.05 raised to power 8. Just input n equal to 8 here. And that gives us some number. You can see what that is: 36,000 multiplied by 1.05 raised to power 8. And that's 53188.4. This is the selling price in 2008. Is that okay? 53188.4. That's the price in 2008. Any questions on this? No? All right, let's move on. Now it says the company that makes the necklace only sells one each year. Find the total amount of money obtained in the 10-year period starting in the year 2000. Now they're starting in the year 2000. What would be the 10-year period? When you start from 2000, 10 years complete in 2009. Right? Because 0 is also included. So 0, 1, 2, 3, 4, all the way up to 9. That's going to be 10 years. Okay, I'm sorry, no, that's not correct. What was happening when was it starting? The selling price in 2000 was 36,000. Okay, that's okay. And in 2000 as well, they're selling something. Okay, that's okay. They're selling something in 2000 as well. And then starting from 2000, 10-year period, what would that become? That will be 2000, 2001, 2002, 2003. But doesn't that period become greater than 10? No, that's okay. 2000 is fine. Now, when do we start? That we start from 36,000. And we know that this is the first term, and we know that the ratio is 1.05. That was the ratio that we were given, that we found earlier. It's a geometric progression. What's the formula that we use for that? The sum formula for a GP. It looks like this. Sn is equal to A into 1 minus R raised to power n divided by 1 minus R. Sum of the first 10 terms. What's that going to be? 36,000 into 1 minus ratio, which is 1.05 raised to power 10, divided by 1 minus 1.05. And you can see what that turns out to be. That will be your final answer. Okay, just calculate this. Now, keep a lookout for this negative sign. This is outside the power. This is not inside the power. So the numerator is going to be negative. Denominator will also be negative, and they will cancel each other out, basically. The negative sign. So the overall result is going to turn out to be positive. Let's see what this turns out to be. 36,000 into 1 minus 1.05 raised to power 10. The power 10 is only on 1.05. Minus is outside. Okay. And then in the denominator, we have 1 minus 1.05. And that is giving me 4,528,004. That is the total amount of money obtained in this 10-year period starting in the year 2000. Okay, and that's what we were looking for. Any problems with this? Any questions, anyone? No? Because when you start from 2000, the next is going to be 1. So you're starting from 0, right? 0, 1, 2, 3. These are 10 numbers in total. You're starting from 0. You're not starting from 1. Okay. If you're starting from 1, that would be different. Then you would end at 10. But here you're starting from 0. When you start from 0, you end at 2009. Right? Because that's when the 10 terms complete. Okay. But in any case, in this case, it does not really matter because we are given that it's 10 years. So we can just use that. Yes, you're right. You're right about that. In this case, since we're given that it's 10 years, we just use 10 from there. But if we were asked to find the price after 10 years, or in fact, that's also okay. If you were asked for price after price in the year 2009, then you have to think about this. The number of terms is actually 10 in that case. But yeah, in this case, it says 10. So you know that we're talking about the value of 10 being, the value of n being 10 here in the formula. Okay. All right. The next question that you ask about is question number 4 from this paper. Let's have a look at that. This is the one. It says state the range of this function f. You've got the graph of the function given. However, we don't have the values on the vertical axis. F of x equals 3 over 2 cos of 2x plus 1 over 2, and x is between 0 and pi. You see, one cycle is being completed here. Now, originally for a cos graph, the range is from -1 to 1, right? The cos graph generally is from -1 to 1. However, we've got some vertical transformations happening here. We are multiplying by 3 over 2. What happens when you multiply by 3 over 2? There's a vertical stretch. The y coordinates get multiplied by 3 over 2. So 1 becomes 3 over 2, and -1 also becomes -3 over 2 because of this vertical stretch. And then what we're doing is we're adding 1 over 2. So the whole graph basically translates upwards by 1 over 2 units. You add 1 over 2 to that because of that. 3 over 2 plus 1 over 2 and -3 over 2 plus 1 over 2. What do you get from that? 2 here and -1 here. So the range of f, that turns out to be between -1 and 2. Or you could also write it in terms of y. You can say y is between -1 and 2. So you can think of transformations. What are the transformations that are happening? First is a stretch, vertical transformation. We don't care about the horizontal transformations here because range has to do with the y coordinates, right? So the range is, the y coordinates are first multiplied by 3 over 2, and then we are adding 1 over 2 to them. So initially they were -1 and 1. -1 gets multiplied by 3 over 2, and 1 gets multiplied by 3 over 2. And then we add 1 over 2 to both of them. And the final result turns out to be from -1 to 2. Okay? This is one possibility. This is one possibility. Another possibility could be to just use the table function on your calculator. Use the table function on your calculator and make a table for all of these values. And from that, you can see that the least value of y in the table, so take values at fairly small steps. So this is from 0 to pi. You can use a step of pi over 8, for instance. Use a step of pi over 8 on your table and see what's the lowest value of y in that table, what's the highest value of y in the table. You will see that the lowest value will be -1 and the highest value will be 2. You can write the range using those lowest and highest values. Okay? All right, so this is what we get in the first part, the range of f. So now we know that the graph is starting from -1 here and it's going up to 2. The function g is such that f of x, it's equal to f of x plus k, where k is a positive constant. The x-axis is a tangent to the curve y equals g of x. State the value of k and hence describe fully the transformation that maps f of x onto g of x. So what is happening here? With f of x, you're adding something. To f of x, you're adding something. Are you adding something outside the function or inside the function? You're adding something outside the whole function. So that's a vertical transformation. Which transformation? You've got plus k. That means vertical translation. Graph is going to move up and down. Since k is a positive constant, that means the graph is moving upwards. And it moves upwards in such a way that the x-axis becomes a tangent to the curve. Now, if the graph moves upwards and x-axis becomes a tangent, the graph is going to look something like this. Right? This is what the graph would look like with x-axis as the tangent. How many units has the graph moved upwards? The lowest point at -1 has moved to 0. That's 1 unit upwards. So what's the value of k? The value of k, therefore, should be 1. Okay? Because that is when the x-axis becomes a tangent to this curve. Okay? And then they're asking you to describe the transformation. What's the transformation? It's a translation, but remember you have to write down a vector for translation whenever you have to describe it. What's the translation vector? It will be 0, 1. Nothing on the horizontal axis, 1 vertically upwards on the vertical axis. That's the translation. When you go from f of x to g of x. Now it says, state the equation of the curve, which is the reflection of y equals f of x in the x-axis. Give your answer in this form, where a and b are constants. Okay, f of x, what was that function? The function was 3/2 into cos of 2x plus 1/2. This is the function. You want to reflect in x-axis. What kind of transformation is that? Is that a vertical reflection or horizontal reflection? Reflection in x-axis means any point that's above the x-axis that goes below, any point that's below the x-axis that goes upwards. It's a vertical reflection. Vertical reflection means we're going to multiply by negative outside the function. So the whole function gets multiplied with -1. What do you get? You get minus into this whole thing. This is what you get after that reflection. Okay, that whole thing gets multiplied by minus. So f of x gets multiplied with negative sign like this. Okay. Now we need to write this in this form. Let's simplify this. It becomes y equals minus 3/2 into cos of 2x minus 1/2. That's the final result that we get from this. Okay. Make sense to everyone? Let's move on. That was question number 4. Let's have a look at the next one. Okay, so the next one that most of you have asked about is question number 8. So the votes for 7 have decreased. So I hope that makes sense to everyone now. 5, 6, 7. Yeah, it's not that difficult. Should be doable. Okay, so the next question is question number 8. Let's have a look at that now. In the diagram, ABC is a semicircle with diameter AC. ABC is a semicircle with diameter AC, center O, and radius 6 centimeters. Okay, it's a semicircle. The length of arc AB is 15 centimeters. This arc is 15 centimeters. That's what we're given. The point X lies on AC and BX is perpendicular to AX. Okay, BX is perpendicular. So you can see all of that in the diagram. Find the perimeter of the shaded region BXC. This is the shaded region that we are looking for. Okay. Now, how do you find the shaded region? We've got the arc length given and the radius given. Can we use those two things to find the angle first of all? Right, because the angle is missing. We don't have any angle here, but we have the arc length given. We can use S equals R theta formula. Arc length is 15. Radius is 6. You can find theta from this. Theta turns out to be 15/6. That's 2.5. It's not 2.5 times pi. So a lot of people just do it or do that. There's no pi here, okay? It's just 2.5. This angle is 2.5 radian. All right. Now that we've got that angle, we need these 3 lengths, BX, XC, and BC. First of all, let's start with the arc length because that is pretty obvious now. Because what's this angle going to be? It's going to be pi minus 2.5. Let me write that down here. Angle BOX, that is going to be pi because the angle on a straight line is pi. Subtract from that 2.5. And that gives you this angle, pi minus 2.5, which is 0.641 6, minimum 4 significant figures because this is working. 0.6416. That's the angle. And now, once we've got this angle, we can find the arc length. Let's find the arc length. Arc BC is equal to R, which is 6 into angle, which is 0.6416. This is the arc length. Multiply this by 6. That's giving me 3.84955. You can say 3.8. I'm just write all of that. 8496. Okay, arc BC. That's the length of arc BC. Now we need to find the length BX and XC. How can we do that? Now, this is also radius, OB, right? OB is also radius. Do we know the length of OB? OB is going to be 6 as well. If this is 6, it's a right angle triangle now. In this right angle triangle, we can find the length BX and also the length OX because one of them is perpendicular, the other is base. BX can be found using sine, right? In this right angle triangle, let's use sine to find BX because BX is perpendicular. We know the hypotenuse. The ratio between perpendicular and hypotenuse is sine. So we could use sine of 0.6416 equal to BX over 6. And that will give you the length BX. Let's see what this turns out to be. 6 into sine. Make sure your calculator is in radian mode. 6 sine 0.6416. And that's giving me 3.5909. That's the length BX. Now we also want XC. For XC, what we can do now is we can find the length OX first, subtract OX from OC. OC is the radius. Let's find OX first of all. What would OX be? For OX, we can use cos. We can say cos of 0.6416. That equals OX over 6, and that will give us the length OX. Let's see what that is. 6 cos of 0.6416, which is 4.807. Once we've got OX, we can find XC now. What would XC be? XC is radius minus OX because OC is the radius. XC equals 6 minus 4.807, and that turns out to be 1.193. We've got all the lengths that we need now. We've got the arc length, we've got the length BX, and we've got the length XT. These are the 3 sides of that shaded region. This is the boundary of the shaded region. We can just add all of them up, and that will give you the perimeter. It turns out to be 3.8496 plus 3.5909 plus 1.193. And that's giving me 8.634. So it's 8.63, correct to 3 significant figures. That's the perimeter of the shaded region that we were looking for. Is that okay? Abdullah, I don't understand your question. Could you rephrase that maybe? What do you mean subtract arcs from triangle? Triangle is a shape, arc is something else. Okay, good. All right. That's the perimeter, okay? Question number 8. Let's move on. So the next one that you've asked about is question number 11. Okay, that's the last question from this paper. Let's have a look at that. It's pretty dark outside already. Question number 11. Let's try this. The diagram shows part of the curve y equals 8 over x plus 2 and the line 2y plus x equals 8. They intersect at points A and B. The point C lies on the curve, and the tangent of the curve at C is parallel to AB. Okay, so if there was a tangent at the point C, they're saying this tangent is parallel to that line AB. What does that tell you about the gradient of this tangent? The gradient of the tangent is going to be the same as the gradient of the line AB, right? Because they're both parallel. So gradient of AB would be the same as the gradient of the tangent at this point. And now they say find by calculation the coordinates of the points A, B, and C. Okay, so how do we find these 3 points A, B, and C? A and B are points of intersection of these two graphs, of these two functions. One is a linear function, the other is a curve. A and B are points of intersection of these two functions. So we can find A and B by just solving them simultaneously. In fact, A is just the y-intercept of both graphs, so that's actually even quicker. Let's find A first of all. 2y plus x equals 8. This is a straight line. If we convert it to standard form, that we need that to find the gradient later on as well. So let's convert it to standard form. That gives us minus x plus 8 and y equals minus 1 over 2x plus 4. 4 is the y-intercept. Right? 4 is the y-intercept of the straight line. That means the coordinates of A therefore are 0 and 4. Okay? Because A is the y-intercept of this function. That's what we get. Or you could input x equals 0 here as well. That also gives you 8 over 2, that's 4. So these are the coordinates of A. What about B? B is the point of intersection of the curve and that straight line. You'll have to solve the curve and the straight line simultaneously now. So you have to do that anyway. Let's try that. This is one equation and the other is y equals 8 over x plus 2. Let's solve these two simultaneously. We've got y, the subject, in both of them already. We can just equate them. We can see. This is what we get when we equate them. Minus 1 over 2x plus 4, that equals 8 over x plus 2. Okay, by the way, our class can probably end at any moment because the weather outside is that it's very highly likely that we won't have electricity in maybe a few minutes, but let's hope that's not the case. Minus 1 over 2x plus 4 equals 8 over x plus 2. Let's solve this simultaneously. What do we get from this? Okay, so first of all, let's take LCM on the left side. That gives us minus x plus a divided by 2. That equals 8 over x plus 2. Let's cross multiply. Minus x plus 8 multiplied by x plus 2. That equals 2 into 8, that's 16. This gives us a quadratic equation. Let's multiply these two. And we get minus x squared plus 8x minus 2x plus 16 minus 16 from the other side. And we've got minus x squared plus 6x equals 0. Take x common, that leaves us with minus x plus 6 inside. X equals 0 or minus x plus 6 equals, and we get x equal to 6. Okay, so we've got x equals 0 and x equal to 6. That means the x coordinate of b therefore is 6. What about the y coordinate? Put this back in any one of those two equations. Let's put that here, and that gives us y equal to 8 over 6 plus 2. Y equals 1. So the point b therefore is 6 and 1. A we already know, so we don't really have to do that. We can do that if you want. That will give you the same result. That's 0, 4. We've got the code at the point B as well now. Okay, that's 6, 1. And now we need the point C. What about C now? C is the point at which if we were to draw a tangent, that tangent is parallel to the line AB. That means the gradient of that tangent is the same as the gradient of AB. What's the gradient of AB? Gradient of AB is minus 1 over 2 from here, right? We've got the equation of the line, minus 1 over 2x plus 4. In the standard form where y is the subject, the coefficient of x, that gives us the gradient. Gradient of AB is minus 1 over 2. And that's also going to be the gradient of the curve. All right, this is also the gradient of the curve at this point C. This is gradient of curve at C, that equals minus 1 over 2. Yes, Abdullah.
Sir, isn't it going to be gradient of tangent?
Okay, let me do it step by step. So if gradient of AB is minus 1 over 2, AB is minus 1 over 2, that means the gradient of tangent is minus 1 over 2. That means this line, the tangent, has gradient minus 1 over 2. What's point C? C is a point on the curve where we are drawing this tangent. The gradient of tangent is the same as the gradient of the, is supposed to be the same as the gradient of the curve at that point. So whatever is the gradient of this tangent, the gradient of the curve at this point will also be the same. Okay. So this also follows from this that the gradient of curve at this point would also be this. Why there's so little space for this 6-point question? Let me take it on the left a bit. Since AB's gradient is minus 1 over 2, we say the gradient of the tangent is also minus 1 over 2. And from that, it also follows that the gradient of the curve at the point C, that is also minus 1 over 2. Okay. And now, what we can do is, we can say, let's find the gradient of the curve at this point and equate that to minus 1 over 2, right? Because how do you find gradient of a curve? You find the derivative. And once you have the derivative, you put the value of x in that. In this case, we've got the gradient already given. We need to find the corresponding value of x at which you are getting that particular gradient. Now, let me explain that. This is the equation of the curve. Y equals 8 over x plus 2. We can write that as 8 into x plus 2 whole power minus 1. That's the curve. How do you find gradient of this curve at any particular point? You find the derivative of this. That's dy over dx. That will be 8 into minus 1 into x plus 2 whole power minus 2 into derivative of x plus 2, which is just 1. So dy over dx turns out to be minus 8 over x plus 2 whole squared. If you want to find gradient of any particular point on this curve, what you have to do is, you just input that value of x here, and you will get the gradient. Now, in this case, we are given the gradient at a particular point. We know that the gradient at the point C is minus 1 over 2. So what we do is we put this gradient, the derivative, equal to minus 1 over 2, and see what value of x that gives us, because that will be the x coordinate of this point C. And that's what we're looking for. Okay. So we put this derivative equal to minus 1 over 2 and see what that gives us. Let's cross multiply. Minus and minus, they get cancelled. we get x plus 2 whole squared equals 16. Take square root on both sides. That gives you x plus 2 equals plus minus 4. And that means x plus 2 equals 4 or x plus 2 equals minus 4. X equals 2 or x equals minus 6. These are the two possible values of x that we're getting. However, on the diagram, you can see the point C is supposed to have a positive x coordinate. So the only possible value here is x equals 2. That's the x coordinate of C. Now you put this back in the equation of the curve. This is the equation of the curve. And you get the corresponding y coordinate from that. Y equals 8 into 2 plus 2 whole power minus 1. And that will be 8 over 4, which is just 2. So the y coordinate also turns out to be 2. So what are the coordinates of the point C then? C is 2, 2. This is the point C that we were looking for. It's 2 and 2. At this point, the gradient of the curve is equal to minus 1 over 2. Is that okay? Any problems with this? Okay, Josefa. A was the y-intercept of both the line and the curve. So you could just find that y-intercept by inputting x equal to 0 in any one of these functions. You can find that y-intercept, okay? That's also a point of intersection. So you also get that point when you solve them simultaneously. This also gives you that. When you solve them simultaneously, you get x equals 0 and y equals 4. You get that point here from the points of intersection as well. Okay, all right. Tangent is a line that has the same direction as the curve at a point. Normal is perpendicular to the curve. So for tangent, you use the same gradient as the gradient of the curve. For normal, you take negative reciprocal of that. Okay. Tangent has the same gradient as the curve. Normal's gradient is negative reciprocal of the gradient of the curve. That's the difference between the two. So for tangent, the gradient is the same as the gradient of the curve. And for normal, it's negative reciprocal of the gradient of the curve. Okay, that's the difference between a tangent and a normal. Okay, that was question number 11, part A. I hope that first part makes sense. Let's look at the next part now. It says find the volume generated when the shaded region bounded by the curve and the line is rotated through 360 degrees about the x-axis. Volume of revolution about x-axis. What's the formula for that? If you are revolving about x-axis, the formula has y squared. Integral of y squared with respect to x. So in order to use this formula, you need y squared as the subject in both the functions. In both functions, y squared needs to be the subject. Now, let's look at this. This shaded part needs to be rotated about x-axis. Do we have the limits for x-axis? Yes, we do now, because this point is 0. That's the origin. And point B, the x coordinate of this point is 6. So the limits are going to be from 0 to 6. All we have to do is find the volume of revolution for the area under the line, all of this region. Find the area under the line. No, don't find the area under the line. Find the volume of revolution when the area under the line is rotated about the x-axis. Subtract from that volume of revolution when the area under the curve is rotated about the x-axis, and that will give you the volume of revolution for this shaded part. So basically, in simple words, you have an upper graph and you have a lower graph. Find the volume of revolution for each of them separately and find their difference. Okay. Now let's try this. We've got an upper graph and we've got a lower graph. Let's deal with them separately. This is the formula that we will be using to find volume. In both these graphs now, the first thing you have to do is you have to make y squared the subject. Upper graph, that's a straight line. That was 2y plus x. In fact, we know what we got when we made y the subject. It was minus 1 over 2x plus 4. Minus 1 over 2x plus 4. This was the equation of the line. That's the upper graph in that shaded part. What's the lower graph? Y equals 8 over x plus 2. That's the other one. You can write that. Yeah, let's actually write it in the same form. Y equals 8 over x plus 2. Now, in order to use this formula, you need y square. Let's square both of them. Let's square the first one. Now, you can do it directly as well and then use a plus b whole squared, and that will work. It will make things slightly easier if you take LCM first and write it like this, minus x plus 8 divided by 2, and then square both sides. Now, when we square both sides, it becomes y squared equals minus x plus 8 whole squared, minus x plus 8 divided by 2 whole squared. That's what it becomes. Now, let's evaluate this. Y squared. In the numerator, we've got a plus b. A is minus x whole squared, that's going to be x squared. And then 2 into minus x into 8, that will be minus 16x, plus 8 squared, that's 64. In the denominator, you've got 4. This is y squared. This is what we need to integrate later on. Okay, that's the upper function. And let's do the same thing for this other one as well. You can say this is y squared equals 8 over x plus 2 whole squared. And that gives you y squared equal to 64 over x plus 2 whole squared. Now we need to integrate both of them. Input the limits 0 to 6. Okay, 0 to 6, these are the limits. Let's integrate them. Volume of revolution about the x-axis. Limits are from 0 to 4. We need to integrate this thing. That's x squared minus 16x plus 64 whole divided by 4. We need to integrate this with respect to x. Now, this 4 is being divided by the whole thing. It will make things easier if we just write this 4 outside. Write it outside with pi over pi, so it becomes pi over 4. Inside, we're just left with this thing. This is what we can integrate directly. What's the integration of x squared? Integration of x squared is x cubed over 3. And then minus 16x, that becomes minus 16x squared over 2. Plus 64, that becomes 64 times x. And limits are from 0 to 4. Okay. Now let's simplify this. Input 4 and input 0 and see what both of them give you. When you input 4, you get 4 cubed divided by 3. Now, inputting these limits is necessary. You have to show the step. Minus 16 into 4 squared over 2. Or you could actually simplify this a bit first before you input values. If it's 16 over 2, that's 8. So that's 8 into 4 squared plus 64 into 4. Subtract from this the case when you input. X equal to 0. So from this case, subtract the case when you input x equal to 0. All terms have x in them, that's multiplying. So they will just evaluate to 0 eventually. Okay. Now you can simplify this and see what this turns out to be. 4 cubed is 64 divided by 3 minus 8 into 16 plus 64 into 4. Divided by 4. And that's giving me 112 over 3 times pi. That's the first volume that I'm getting from this. Okay, volume of revolution for the area under the graph. Area under the straight line that we had. Now do the same thing for the other function. Let's integrate this as well and find the volume of revolution from this. What does this function look like? Integration of 64 into x plus 2 whole power minus 2 with respect to x. Limits are from 0 to 6. Now pi outside remains as it is. We can write 64 outside as well if we want, right? Because that's just a constant multiplying by the whole thing. It's okay to write that outside, 64 pi. And now we need to integrate x plus 2 whole power minus 2. Now the expression inside the power, that is linear. So we can use the power rule here. If it was not linear, we would have to do something else. What do we get from this? X plus 2, add 1 to the power, it becomes minus 1. Divide by the new power, that's minus 1. And also divide by the derivative of this thing, that is 1. This is the integration. And now you input the limits from 0 to 6. Now, before we do that, in fact, we should just simplify this a bit more. It becomes, this is negative, right? Let's write that negative outside. So it becomes minus 64 pi. And then we have 1 over x plus 2 inside, right? This is negative 1. We can take that to the denominator and write this as x plus 2. Let's input limits now from 0 to 6. Minus 64 pi remains outside as it is. Inside, we input 6, and that gives us 1 over 6 plus 2. Subtract from that the case when you input 0, and that gives us 1 over 0 plus 2. And now let's evaluate this. 1 divided by 8 minus 1 divided by 2 multiplied by 64 into minus 1, and that will be 40 pi. That's what I'm getting for the second volume. And now, okay, I'm sorry. Yeah, thank you for pointing that out. This was actually 0 to 6. I wrote that as 0 to 4 there for some reason. Let me change that. It was actually 0 to 6. In the first case, it was 0 to 6. So this should have been 6 inside here. So that becomes 6 cubed minus 8 into 6 squared plus 64 into 6. Okay, let me actually calculate that other thing again. 6 cubed divided by 3 minus 8 into 36 plus 64 into 6 divided by 4. That's actually 42 pi. The first one, that's giving me 42 pi. Is that okay? Can somebody confirm this as well? Do we get 42 pi from the first one? You can actually just confirm the other one as well now. The first one is 42. What about the next one? Have we input the correct limits here? Yeah, we have. Let's just check the rest of the working as well. 64 into x plus 2 power minus 2. We add 1 to the power. It becomes, function was correct. X plus 2 whole squared. That was also correct. Add 1 to the power, divide by that, minus goes outside, minus 64 pi. Then we have 6 and 0 as the limits. Okay, let's evaluate this. 1 divided by 8 minus 1 divided by 2. Yeah, that's not this as well. I put something else earlier here. Into 64. Yeah, so this is 24 pi. Okay, so there were some calculation errors there. I'm sorry about that. This is what we're getting for the two volumes. And now we find their difference. The required volume, let's see what this turns out to be. The volume is going to be 42 pi minus 24 pi, and that is 18 pi. Okay, so that's what we get. Not that difficult, apart from the fact that you can do careless errors like this, which end up making you lose marks. Okay, any problem with this? No problems? It's a standard problem where you just find the volume of revolution under for one graph, subtract from that the volume of revolution of the other graphs, and that gives the result. That was question number 11. And that completes our first paper. Okay. Let's have a look at the next one quickly now. These were the difficult questions in the first paper that you asked about. Now let's move on to the second one, which is June 2020, paper 1, variant 3. Let's start that. Make sure to have a look at the paper again if you haven't already, and let me know the questions that you find difficult from this paper now. June 2020, paper 1, variant 3. By the way, in the next class, we will be doing June 20, paper 1, 2, and March 2020, paper 1, 2. All right, difficult questions from those two papers on Monday. And then on Tuesday, inshallah, we will be doing 2 2022 papers. I think I've posted that in the WhatsApp group as well. And then on Wednesday, we would have a longer class in which you can ask any questions. Now that's up to you. You can come for maybe 15, 20 minutes, 30 minutes in that class, ask your questions, and leave, because that will be the last day before exams. You'll have maybe other priorities as well, as in you may have some notes to revise, etc. What would you suggest about Wednesday, by the way? Your exam is on Thursday, right? So I'm planning to have a class where you can ask any questions that you have. Is there anything else that you would want to do that day on Wednesday, if you would be attending the class? It would not make sense to do a paper that day, because then we'll be restricting ourselves to only one particular paper from one particular session. Summary of the syllabus, well, that will be a bit too long, as in that will take like 6-7 hours to do a summary of the whole paper. Yeah, if I give you only the hard questions, that will be demotivating you a lot the day before exam. So, okay, so one idea is, so what I'm thinking of is that one idea would be that you just come up with your questions, ask your questions, and leave. Because you should have your day planned as well about revision, as in you should be clear what notes you need to revise that day. So you'll be spending a lot of time on that. You'll be looking at everything that you've done until now. So maybe you'll just looking at all these papers that you've solved, looking at the solved solutions, not actually doing much by hand the last day, but just looking at the solved solutions, thinking, keeping, trying to retain everything, the different concepts that you've done. Okay. For a summary, what I'll do is, I'm not sure if most of you have seen those videos already. What I'll do is I'll actually share with you some quick revision videos, and they're basically there for every single topic, and they cover, they basically give you a good revision of all the concepts that you need to know about from each topic, from each paper one topic. I'll share those videos in the group at some point, maybe over the weekend. You can have a look at that. And then after you're done with that, after you've gone through those revision videos, you can let me know if there's any particular concept that you do not understand. Maybe you could just focus on that concept that day for a few minutes, and I could explain those particular concepts to you, those of you who asked about them. I'll share those videos in the group. You can skim through them, 1.5x, 1.75x. You've got the notes for them in the WhatsApp group's description as well, I think. So you can go through that as well, and they should be helpful. About mechanics, well, mechanics is going to be on 7th May. There's still time for that. So we will do the session before mechanics classes, before the mechanics paper as well. On Wednesday, by the way, we won't have a mechanics class. Okay. On Wednesday, it will only be paper one because many of you will be sitting for paper one. In fact, all of you will be sitting for paper one, and then most people who are taking mechanics, they will also be sitting for paper one the next day. So we won't have the mechanics class on Wednesday. That's not going to happen. Okay. So before the day before exam, we will only be focusing on the exam that you have the next day. All right. So we'll have like a 3-4 hour session only on paper one. And as I said, you can come and go. You don't have to attend the whole session because you have to think about what is best for you at that time. What topics you still need to revise. Your time will be most likely be better used in revising those particular concepts rather than looking at what other people are asking here. So you can come, ask your questions, leave. So we could do something like that. If there are any specific concepts that you want to do, we could also go through those concepts very quickly. We will not be able to do that in much detail. If there are any concepts that you do not understand, you've got detailed videos for them in the group's description. You can have a look at that as well. Okay. Yeah, at night, as in how more at night you can do, as in if we do 5 p.m. to 8:30 p.m. something, I think that's so for most people in Pakistan that will be evening. So between Maghrib and Isha. After that, we can't prolong it for too long because you need to have good sleep for math exams as well. Otherwise, you'll be making careless errors like I do here. So you don't want that. You want good sleep before exams. So we can't stretch it for too late in the night. Okay, let's actually start with our next paper. June 2020, paper 1, variant 3. Let's do some difficult questions from this paper now. Again, you can give suggestions in the WhatsApp group as well if there's anything else in your mind. I'll share the quick revision videos, and hopefully for revision, you would find those videos helpful. Make sure to go through them a couple of videos every day from now on, and that should cover all of them. But let's start with this for now. Paper 1-3, June 2020. Okay, so let's see which questions you've asked from this paper. 1, no. 2, no. Okay, let's start with this one. Question number 3. It says in each of parts A, B, and C, the graph shown with solid lines has the equation y equals f of x. The graph shown with broken lines is a transformation of y equals f of x. State in terms of f the equation of the graph shown with broken lines. Okay, so this solid graph is the original graph, and the graph with broken lines, that is the transformed graph. What transformation is this? How do you go from f of x to this graph? This is reflection in y-axis. Line of reflection is y-axis. Do you call this vertical reflection or horizontal reflection? This is called horizontal reflection because the movement of the graph is horizontal. So what happens in horizontal reflection? Something changes inside the function. The original function was f of x. When there's reflection, it becomes f of minus x. So we multiply by negative sign inside the function like this. All right, that's the first one. Now, what about the second one? You see, the shape of the graph is changing. That only happens in stretch, right? Because in reflection and translation, the size of the figure, the shape of the figure, that remains exactly the same as before. That does not change. So this, of course, has to be a stretch then. In which direction? Horizontally, you can see the graph was 2 units wide, and after transformation as well, it's 2 units wide. So horizontally, there's no stretch. Vertically, it was 2 units earlier, and now it becomes 4 units. So that's vertical stretch by a factor of 2. You can see the point at 1 has gone to 2, the point as 2 has gone to 4, the point as 3 has gone to 6. That's a vertical stretch, scale factor 2. How would the equation look like? We multiply by 2 the whole function. The whole function gets multiplied by 2. So y equals 2 times f of x. It's a vertical stretch, right? So multiplication has to be outside the function. That's what you get here. Y equals 2 into f of x. And then finally, you need to state the equation of this graph. What transformation is this now? The graph has moved to this this region in the 4th quadrant and the 3rd quadrant. What transformation is this? The graph has shifted position. It's a translation. How many units to the left and how many units down? Let's count them. Let's take any corresponding points. Let's take this point here and this point. 1, 2, 3, 4. 4 units left and then 3 units down. 4 left, 3 down. Translation vector would be -4 and -3. That means 4 left and 3 down. What does the function look like? Y equals f of x something, and then outside you've got something added or subtracted. Now, 4 means, -4 means, so 4 left means inside the function you're either going to have +4 or -4. And 3 units vertical translation means outside the function you're either going to have +3 or -3. Now, which one of these are we going to have? In vertical transformation, if you're going downwards, that means you're subtracting 3. That's -3. Downward means minus, upwards means plus in the function. So outside, it would be -3. What about inside? In horizontal transformations, everything works counterintuitively. It works the other way around. If you're going right, you have minus here. If you're going left, you have plus here. In this case, you're going left. For left, in horizontal transformation, you would have +4 here. Okay? +4 inside the function would mean that you're going to the left side. And that's what the equation becomes. F of x plus 4 and then -3. We do +4 inside the function for horizontal translation and then -3 outside the function for vertical transformation. All right, that's the graph. That's the function that we get. Let's look at the next one now. That was question number 3. Okay, so there are no votes for this one. We have 5. Okay, let's do 5 now. It says the diagram shows a cord going around a pulley and a pin. Okay, so this is the pin and this is the pulley. And you have a cord going around these two things. So this is the whole cord. The pulley is modeled as a circle with center and radius 5. You can see that the thickness of the cord can be neglected. The pin is situated 13 centimeters vertically below O. A and B are in the circumference of the A plane. Okay, so these are tangents. This is the tangent. This is the tangent. Cord passes over the major arc. And so the cord is cord. Calculate the length of the cord. Okay, so all the information is given here in the diagram. You just have to find the length of all of this region. Okay, length of this, basically perimeter of this whole chip. Okay, that's basically 3 lengths: PB, AP, and this arc length. You just add all of these up, and that will give you the length of the whole cord. Now, how do you find these lengths? AP and PB are pretty straightforward because these are right angle triangles. This is a right angle triangle. We can find AP. Let's say AP is the base, 5 is perpendicular, 13 is hypotenuse, 15 is Pythagoras. And we can say AP squared plus 5 squared equals 13 squared. And that will give you the length AP. You can see what that turns out to be. 169 minus 25, 144, that will be 12. AP equals 12. And BP, therefore, is also going to be 12. It's the same. It's a congruent triangle. That's also the same. BP is also 12. And now the problem is we need to find the arc length for this green part. How do you do that now? You need an angle for that. Radius is already given. Radius is 5. You want this angle somehow. How can you find this angle? Again, you can use this right angle triangle. this right angle triangle. Find this angle. Let's call this angle X. How do you find this angle? You can use any ratio that you want, sine, cos, tan, because we've got all three sides now. This is 12, this is 12. Sine, cos, tan, any ratio. Let's use cos for using 5 and 13, the sides that were already given. Cos of X would be base, which is 5, over hypotenuse, which is 13. And that will give you X. What is that? Cos inverse of 5 divided by 13. And that's giving me 1.176. That's the length of X. If this is X, this is also going to be X, right? Remember, it's a kite. Tangents coming from outside a circle from one single point. The shape is a kite. And these angles are the same. These angles are also the same. So if one is X, the other is also X. We found the value of X. What about the angle of that sector now? Let's call that angle theta. How can you find the angle theta? Subtract from 2 pi these two x's and see what that gives you. Theta, which is the angle of that sector, that's 2 pi minus 2 into 1.176. What do you get? That's 3.931. That's the angle of that sector. Now you can find that arc length. Arc AB, that's radius, which is 5, into the angle, that's 3.931. What do we get from this? 19.66. And now you can find the length of the chord, the total length of the chord. That will be just the sum of these three lengths now. AB, AP, BP, and this arc length. What do you get from that? 12 plus 12 plus 19.66, and that gives you 43.66. We can say that's 43.7, and that's your final answer. That's all that you had to do here. Is that okay? Wasn't that very straightforward? So that basically tells me that you're just looking at the question and seeing, okay, this looks tricky, without actually attempting them. Because this was quite straightforward, right? No problems? Okay, let's have a look at the next one now. So the next one is question number 6. Okay, again, it does not look that difficult. Let's try this. A point P is moving along a curve in such a way that the x coordinate of P is increasing at a constant rate of 2 units per minute. So that's dx over dt, rate of change of the x coordinate, dx over dt, that equals 2. Equation of the curve is y equals 5x minus 1 whole power 1 over 2. Find the rate at which the y coordinate is increasing when x equals 1. That means we want to find dy over dt when x equals 1. How do you find dy over dt? You can use chain rule for this. Dy will be the numerator of the first fraction, dt will be the denominator of the second fraction, and in the remaining places we've got the third variable, that's dx here. So dy over dt equals dy over dx into dx over dt. Dx over dt is already given. We have to find dy over dx. How do you do that? Differentiate this. Dy over dx, that turns out to be 1 over 2 into 5x minus 1 raised to the power minus 1 over 2 multiplied with the derivative of what's inside, that's 5. And you can see what this turns out to be. You can input the value x now. We wanted to find the rate of change of y when x was equal to 1. Let's input x equals 1 here and see what that gives you. Dy over dx from this equals 5 over 2 into 4 raised to the power minus 0.5. That's 5 over 4. That's dy over dx. Now you just input these values in this chain rule and that will give you the result. 5 over 4 multiplied by 2, and that's 5 over 2, which is 2.5. That's the rate of change of the y coordinate when x equals 1. Okay, that's the first part. Let's move on. Now it says find the value of x when the y coordinate is increasing at 5/8 units per minute. So now we know that dy over dt, that is 5/8. Dx over dt was constant. That was 2. Dx over dt was 2. We need to find the value of x from this. Now we've got dx over dt and dy over dt. What we can do is we can find dy over dx from this. What's that going to be? Dy here as the numerator, dx is the denominator here, and in the middle you've got the third variable, dt, and that gives you 5/8 multiplied by 1/2, which turns out to be 5/16. That is dy over dx. Now we need to find the value of x when dy over dx equals this. How can you find that? We have dy over dx already. The function for that was here. We found the derivative in the first part. We can say dy over dx, that was equal to 1/2 into 5x minus 1 whole power minus 1/2 into 5. We want to find the value of x when dy over dx equals 5/16. We can input 5/16 here, and that gives us 5/16 equals 5/2 into 5x minus 1 whole power minus 1/2. Let's simplify this. Let's take this there and this there as well. And that gives you 1/8 equal to 5x minus 1. Let's write this in the denominator because the power is negative. And if we write this in the denominator, the power becomes positive. Now cross multiply and you get 5x minus 1 power 1/2. That equals 8. To get rid of the power 1/2, square both sides. When you square both sides, that gives you 5x minus 1 equals 64. 5x minus 1, 5x equals 65, and the value of x turns out to be 13. And that's what we were looking for. Okay, x equals 13. So using dx over dt and dy over dt, we found a value for dy over dx. Then put dy over dx equal to that value. That gives you the corresponding value for x. Okay. Again, not that difficult. Let me look at the next one. So next we have question number 8 and question number 11. So let's do these two questions quickly and then we end for today. 8 and 11. Okay, so the first term of a progression is sine squared theta. And the second term of the progression is sine squared theta cos squared theta. Given that the progression is geometric, find the sum to infinity. Okay, so it's a geometric progression. And the first term is sine squared theta. The second term is sine squared theta into cos squared theta. We need to find the sum to infinity. What's the formula for sum to infinity? It's a over 1 minus r. What's the first term? A equals sine squared theta. What about ratio? Sine squared theta into cos squared theta. That's the second term divided by the first term. The ratio is cos squared theta. That's the ratio. Okay. Now put these values in the formula and see what that gives you. A is sine squared theta divided by 1 minus r. That's 1 minus cos squared theta. What is 1 minus cos squared theta? 1 minus cos squared theta is sine squared theta. So that gives you sine squared theta over sine squared theta. And that turns out to be 1. That's the sum to infinity. It's 1. Okay. That was the first part. Now let's look at the next one. It says, it's now given instead that the progression is arithmetic. Find the common difference of the progression in terms of sine theta. So now it's an arithmetic progression. And the first term was sine squared theta. And the second is sine squared theta into cos squared theta. What's the difference? Second term minus the first term. That gives you sine squared theta into cos squared theta minus sine squared theta. You want to give a result only in terms of sine theta. So you need to get rid of That gives you sine square theta minus sine raised to power 4 theta minus sine square theta. And that leaves you with minus sine raised to power 4 theta. These two terms get cancelled. This is the common difference, minus sine raised to power 4 theta. Okay, that's the second part. Again, pretty straightforward, right? And now it says find the sum of the first 16 terms when theta equals pi over 3. Now, they have given us that the sequence is arithmetic. It's an arithmetic sequence. The first term is sine square theta. Let's actually find these first terms first. The first term and the difference first. A is sine square theta. And difference we found to be minus sine raised to power 4 theta. Let's input that value of theta here. What's the first term going to be? Sine of pi over 3 whole squared. And difference is minus into, remember this minus is outside. And then inside you have sine of pi over 3 whole raised to power 4. Now, since they don't want an exact answer necessarily, you can evaluate this from a calculator directly and see what that gives you. Sine of pi over 3. If they wanted an exact answer, you would have to show steps for that. Okay, but in this case, they don't want an exact answer necessarily. So you can just put this whole thing on a calculator. Sine pi over 3 whole raised to power 2. And that gives me 3 over 4. That's A. Sine pi over 3 raised to power 4. That's minus 9 over 16. And now what are we looking for? Sum of the first 16 terms. It's an arithmetic progression. The sum formula looks like this. A into, sorry, this is arithmetic. That's half into n into 2a plus n minus 1 times the difference. Let's just input values in this. 1 over 2 into n. So we're looking for sum of the 16 terms. 1 over 2 into 16 multiplied by 2 into a, which is 3 over 4 plus n minus 1. That means 16 minus 1. That's 15 times the difference, which is minus 9 over 16. And that should give you the result. Anyone who can tell me what this result is? 8 into 3 over 2 minus 15 into 9 over 16. That's minus 55.5. That is the sum of these 16 terms. And that's what we were looking for in this last part. Again, looked difficult, but it was actually not that difficult. Fairly straightforward, right? That was question number 8. Yeah, question number 8. Let's move on. This is 9. It's function problem. You have to complete the square and then state the smallest possible value of c. For this to be a one-to-one function, that will be the turning point. And then find f inverse and this, state the range of gf. Okay. The last part, this might be slightly tricky. Make sure to try this, but nobody has voted for this. So I'm assuming you've done this, or maybe it does not look that difficult. Question number 10, perpendicular bisector. This also looks like a good question, by the way. Let me just give you a hint, since I guess you haven't tried this yet. In the first part, they have asked you to find perpendicular bisector of this. A and B are basically 2 points. And a circle passes through these 2 points. So A and B will be somewhere on the circumference. We don't know where they are. A will be on the left and down. So yeah, so maybe A is somewhere here and B is maybe somewhere here. And in the first part, they ask you to find equation of perpendicular bisector of this. You've done that. You found the equation of this perpendicular bisector. And then in the second part, they basically say there's a circle that passes through the points A and B. So that will look like this. Its center lies on this line. So its center lies somewhere here, let's say. This is the center. You need to find the equation of the circle. What do you need for the equation of the circle? You need the center and the radius. How would you find the center for this? Because once you have the center, finding radius is not that difficult. You can find the radius after that by just finding distance of C from A or of C from B. That's straightforward. But how do you find the center? That's the question. They have given you that the center lies on this line. And in the first part, they made you find the equation of the perpendicular bisector of AB. What's the perpendicular bisector of AB? If this is the line AB, this is a chord. Perpendicular bisector of AB, that will look like this. And that will also pass through the center of the circle. This is a property of circles, that perpendicular bisector of every chord in a circle passes through the center. So this equation 3x plus 2y equals 11. The equation of the perpendicular bisector that you found in the first part, this line also passes through the center. So that line passes through the center, and you have another line that passes through the center. You can find the coordinates of the center by solving this equation and this equation simultaneously, because they will be intersecting at the point C. All right, the other line has a gradient of 12/5. That might look like this. The other line, maybe something like this. 12x minus 5y equals 70. To find the coordinates of the center, you would solve these two equations simultaneously. This, they have told, passes through the center. For the other line, you need to figure out yourself, since AB is a chord in the circle, and this is the perpendicular bisector of that chord. How do you find? So you know this property that perpendicular bisector of every chord in the circle passes through the center. So the perpendicular bisector here will also pass through the center. This OneNote is becoming very annoying. Okay. All right, so that's the idea. Perpendicular bisector will also pass through the center. You solve those two equations simultaneously, get the center. Once you have the center, you find the distance of the center from either A or B. That will give you the radius, and you can write down the equation of the circle after that. Okay, that's question number 10. Let's move on to question number 11. That's what most of you have asked about from this paper, and then we end with this. The diagram shows part of the curve of the equation y equals this, and the line OA, where A is the maximum point of the curve. The x coordinate of A is small a, and the curve has a minimum point at B0. You can see that as well. Show that B equals 3a. Okay, so we need to find some relation, some equation between B and A. How can we do that? B is the x-intercept of the curve. Let's use that. Y equals x cubed minus 2bx squared plus b square x. If we put y equal to 0, no, in fact, b is already there. So we actually need to connect that to a somehow. Let's think about a first. A is the x coordinate of this turning point. How do you find turning point of a function? You find the derivative, put that equal to 0. Let's start with that, because b is already here in this equation. In order to connect b to a, we need to think about a. A is the turning point of this curve, one of the turning points of the curve. How do you find turning points of a function? You find the derivative, put that equal to 0. The derivative here is going to be 3x squared minus 2b into 2, that's 4b times x. B square x, derivative of that would be just b squared. Remember, b is a constant, right? So in the second term, let me do steps for this. 2b is a constant that remains as it is. You multiply by the power, subtract 1 from the power. And here as well, b square is a constant that remains as it is. Subtract 1 from the power, it becomes x power 0. That's what you get. Now you put the derivative equal to 0. And on the right side, you get 3x squared minus 4bx plus b squared. Okay. This is how you find the turning point of this function. Now we know one of the turning points of the function is when x equals a. So what you can do here is, since you're looking for the turning point, let me write this here. You can say, since we're looking for the turning point, let's input x equals a and dy over dx equal to 0. Because when x equals a, you can say the derivative is 0. It's the turning point. So you can put these two things together. You can say, let's input a in place of x and put the derivative equal to 0. And this is what we end up getting. Is that okay? Any problem until this point? So we just found the derivative, put that derivative equal to 0. And now we've got an equation that connects a and b. We somehow need to prove that b equals 3a from this. Now, since we just need to show this, one idea could be, and that will be easier to do, that you just put b equals 3a here and prove that this equation satisfies. That means b equals 3a. You just need to show that, right? So if we just put that here, you can see what that gives you. 0 equals 3a squared minus 4 into 3a times a plus 3a whole squared. Let's simplify this, and that gives us 3a squared minus 12a squared plus 9a squared equals 0. Everything gets cancelled, we get 0 equals 0. That means b equals 3a because it's satisfying this equation. Okay, this could be one way of doing this. Another way could be, I think, by trying to factorize this. You can see if this can be factorized somehow. Middle term breaking, you've got 3 there. Just like you used to do in O-levels earlier. Break this middle term somehow and try to factorize this. Can you do that? 3 and 1. You can actually break it down like this. You can say this is 0 equals 3a squared minus 3ab. ba is the same thing as ab, right? Or can you just write ba? Minus ba plus b squared. And now take something common from the first two terms and from the second two terms. Let's see what that gives us. 3a into a minus b, right? Minus b, you have a minus b. You get two factors from this, 3a minus b and a minus b, which means either b equals 3a or b equals a. This is not possible because b and a are not the same points. These are different points. So we get b equals 3a. This could be another way of doing this. Okay, you can do it both ways. This is, I think, easier because since they have asked you to show this, you can just input b equals 3a in this equation that you got and show that it satisfies the equation, and that's enough. All right, make sense? No problems? All right, let's move on. Let's move on to the next one. That was part A. Let's look at part B now. It says, show that the area of the shaded region between the line and the curve is Ka raised to power 4, where K is a fraction to be found. Okay, so the area of the shaded region between the line and the curve is Ka raised to power 4. So in terms of A, you've got to find the area. Okay. And that's the last part. Okay, let's try this. How do you find the shaded region? You can do this by integration. Find the area under the curve from 0 to a. Your answer has to be in terms of a, right? So you don't have to find the value of a here. It has to be in terms of a. What you can do is you can find the area under the curve, all of this region. Subtract from that the area of this triangle. Now, finding the area of the triangle is pretty straightforward. You can use half into base into height. You know the base of the triangle, that's a. What about the height of the triangle? How do you find the height of the triangle? Put x equals a in this equation. Let's do that. Let's find the area of the triangle first of all. Y equals x cubed minus 2bx² plus b²x. Okay. What we can do is we can first input x equals a in this function. Why are we doing this? Because we are looking for this particular point A. We already know the x coordinate of a, that is a. What about the y coordinate in terms of a? Let's figure that out. For that, we input x equals a in this function and see what that gives us. Y equals a cubed minus 2b a² plus b²a. Now, since we want our final answer to be in terms of a only, we know now that b equals 3a. So in place of b, we can input 3 times a. So it becomes a cubed minus 2b. In the first part, we proved that b equals 3a. Let's put that here. In place of b, let's input 3a into a² plus 3a whole squared into a. Let's simplify this now. This gives us a cubed minus 6a cubed plus 9a cubed. And that gives us 10 minus 6, which is 4 times a cubed. This is the y coordinate of the point A. The point A, therefore, is a and 4a cubed. Okay. This is the point A. And now what we can do is we can find the area of this triangle. We know the base. We know the height now as well. The height is going to be 4a cubed. What's the area of the triangle? Area of the triangle, that's half into base into height. That will be half into a into 4a cubed. And that gives you 2a raised to power 4. That's the area of the triangle. That's one thing that we were looking for. Once we have the area of the triangle, what we can do now is we can find the area under that curve. We've got this curve now. We just integrate this curve, input the limits from 0 to a now, and see what that gives us. Y equals x cubed minus 2bx² plus b²x. Area between a graph and x-axis. What's the formula for that? Integral of y with respect to x. Limits are from 0 to a. Let's integrate this to find the area. That gives us integral of x cubed minus 2bx² plus b²x. We need to integrate this with respect to x. Limits are from 0 to a. Let's do that. Let's integrate and input the limits. We would get x raised to power 4 divided by 4 minus 2bx³ divided by 3 plus b²x² divided by 2. Right? This is what we get for this integral. Now, once we found this integral, now we can input the limits from a to b and see from 0 to a and see what that gives us. Let's input these limits now. Let's input x equals a first of all. When we input x equals a, that gives us a raised to power 4 divided by 4 minus 2b a³ divided by 3 plus b²a² divided by 2. Subtract from this the case when you input 0. When you input 0, since all terms contain x, all terms are multiplying by x, all of those are going to become 0. So we just subtract 0 from this basically, or you can just ignore that as well. And now you simplify this a bit. Now, again, you know that b equals 3a. We want an answer in terms of a only. So in place of b, what you can do now is you can input 3a. Let's do that. We've got a raised to power 4 over 4 minus 2 into 3 times a into a cubed divided by 3 plus 3a whole squared multiplied by a squared divided by 2. Let's simplify this and see what that gives you. 1 over 4 minus 2 plus 3 over 2. And that gives me minus 1 over 4 a raised to power 4. Is that possible? We're getting a negative result here. Is a positive? A is supposed to be positive. If a is positive, that means we can't be getting, yeah, in fact, yeah, so there's something wrong with this then, because we can't have something negative at the end. Can somebody please verify the calculations? Let me check this again. X cubed minus 2bx squared plus b squared x minus 2bx squared plus b squared x. Okay, let's integrate this. X power 4 over 4 minus 2bx cubed over 3 plus b squared x squared over 2. It's fine until this point. When we input x equals a, that gives us a raised to power 4 over 4 minus 2ba cubed over 3 plus b squared a squared over 2 minus 0. Then we input b equals 3a. B was 3a, right? Okay. B was 3a. So 2 into 3a. And then, okay, I'm sorry. So when I put this in my calculator, I put this as 3. Let me actually simplify this first before inputting this in my calculator. A power 4 over 4. I can actually write it like this first. 1 over 4 into a raised to power 4 minus 2a raised to power 4, because 3 and 3 get cancelled here. And there's a square here. I forgot to do that. So for 3, so it becomes 9 over 2, a raised to power 4. Now let's put this on our calculator. 9 over 2 minus 2 plus 1 over 4. And that's giving me 11 over 4. That's something positive. So that makes more sense. And it's greater than this as well. So it should be greater than that. 11 over 4 into a raised to power 4. That's the area under the curve. We've got the area of the triangle. We've got the area under the curve. All we've got to do now is subtract from the area under the curve, area of this triangle, and we would get that shaded region. So now we just need to find the difference. Okay. Shaded area now becomes 11 over 4 into a raised to power 4 minus 2a raised to power 4. And that simplifies to 3 over 4 into a raised to power 4. And that's our final answer. This is the form, if you compare with that, k a raised to power 4, what's the value of k that you get? K equals 3 over 4, and that's what we were looking for. We've got the value of k. In fact, we have to find the area, not k. You just write k there. This is the actual answer, 3 over 4 into a raised to power 4. Make sense? Any problem with this? No questions? All right, good. So make sure that you attempt these papers yourself as well. In the next class, we will be doing June 2020 paper 1-2 and March 2020 paper 1-2. That they'll be the last papers that we do from 2020. And then on Tuesday, we do 2 papers from 2022, inshallah. All right, and then we will be done with all the papers from 2020 to 2023. Some of them live and others are available as recordings. All right, so that's it. I'll see you again in the next class. Allah Hafiz. Usias, what do you mean? You mean the PDF of the paper? Is that what you want? or the solved paper? What exactly are you asking for? Solved paper or the unsolved paper? Okay, all right. Allah Hafiz.